right, so here's my data, velocity as a function of mass. And you can see they're inversely related. As the mass increases, the velocity decreases. And it's definitely not linear. We want to transform this graph. So let's take a look at the math. So we have the spring energy, 1/2 kx squared equal to the kinetic energy of the person sliding across the ice, 1/2 v squared. And we need to rearrange this equation with, we had velocity as a function of mass, but it was looking like this. So we're going to linearize it. But we know v is on the y-axis, so we're going to isolate v. So let's multiply each side of this equation by 2 and get kx squared equals mv squared. And then let's divide each side of the equation by m. So we'll divide by m. And then we're left with, I'm going to flip it around, v squared equals kx squared divided by m. Okay. And we need to figure out how to linearize this, so we need to isolate the m. So we're going to rewrite this as kx squared times 1/m. That's how we do that. So we're going to graph v squared on the y-axis. Right, we'll put v squared right here, and we'll graph 1/m on the x-axis, and we should get a linear equation. So right, we'll have y, this is our y term, equals slope, this is our slope value, and this here is our x variable graphed on the x-axis. And that's precisely what I did. So on this graph, what I've done is I created another column called v squared, and it automatically calculated those for me, which is great. And then I took my mass and I wrote 1/m1, and it automatically calculated 1/m for me as well. Now these are tiny values, so notice I went into my settings over here, and I had to set my x value is really small. My largest x value was 0.03, so that's why I'm only going to 0.05. And my v squared values went up to 36. No, they went up to 144. So you can see this value right here. That's the 144. So, but it is super linear. And I played around with my slope value until I got a slope of 4,300. So what the heck is 4,300? Well, when we were doing our calculation, it was kx squared times 1/m. Right? Notice I have 1/m graphed here and v squared graphed here. So I can set 4,300 equal to kx squared, and I should be able to calculate k. Let's see if it works. All right, so we have kx squared from our previous math. That was our slope, equal to, according to the graph, it's 4,300. So I should be able to solve for k. So k is going to be equal to 4,300 divided by x squared. And I was pulling the spring back 2 meters. So that would be 4,300 divided by 2.0, it was 2.0 to be precise, meters squared, right? And I think I can do that one in my head. 1,075. So I get a k value of 1,075 newtons per meter, and that is very close to the k value that we were actually using, which was 1,100. So let me pause and go back to the energy transformation lab. So you can see here I was using a spring constant of 1,100, which is very close to the value I got using the graph.